In these sections, we'll cover basically how to graph a quadratic function, and we'll get into more what the equation looks like. But right now, we're just talking about like what the shape looks like. When you graph a quadratic function, we are going to be dealing with a shape called a parabola. So we, instead of a line, we're gonna have like this curve shape here. So notice a couple of key features of it. You've got, some x-intercepts, so it might cross more than once. We got a y-intercept here. We got something called a vertex. A vertex is like the lowest point, or it could be the highest point if the curve goes the other way there. Notice it's kind of a unique point. It's the only one of its kind. Versus like if I look at this point, there's like a mirror image on this side. Or if I look at this x-intercept, there's a mirror image on this side. And same with this point, that's because of the axis of symmetry. If you fold along this line, this curve will match up, and you get basically this duplicate points here. But the vertex is the only one of its type. So it'll be the lowest point or the highest point. And therefore, we can classify it as either a maximum or a minimum. Now, my students sometimes mix these up because they're looking at like the graph, like this graph keeps going down, so you think it has a minimum, or this graph keeps going up, so it has a maximum, but that's not how it works. What we're talking about is the actual vertex itself. This is the highest point we reach, so the vertex is a maximum. This is the lowest point you reach, so it's a minimum. Here are just some ideas of where you could see this be used in the real world situation. For example, maximizing profits. If you got something that costs a certain amount, there's kind of a sweet spot where you can maximize your profits. If you charge too little, you're not going to make enough money. If you charge too much, people aren't going to buy it. But if you charge just enough, you'll make the most profit. And this is what companies actually look at. Or if you think about when you throw a basketball, that path can be modeled by a parabola. So let's see what it looks like. Now, we're going to talk about the parent function here first. So y equals x squared. Here's what all the quadratics will have an x to the second power. So you can look at some of the other examples here. See, there's an x to the second power. There's some other numbers. As you keep going on, there's more numbers, but there's always going to be an x to the second power. So that's what makes it quadratic. Okay, so this parent function is when there's no other numbers involved here. So it's like the simplest thing you can get. You notice there's a lot of simple numbers used here, like just 0. In order to graph this, there's no trick like y equals mx plus b. What you really need to do is you can use your graphing calculator. Mine's having a little bit of issues, and if you have any issues, please just reach out to me. Another great place to go is Desmos. They have a free graphing calculator there. I just typed in y equals x squared. It graphs it for you. And all you got to really do is just look for some key points. So for example, this one goes through 0, 0, through 1, 1, looks like 2, 4, and so on. So just look for some key points that help you out. Okay, and that's how I got this graph here. You can use a table if you need to. Just plot as many points as you can. So the vertex is that key point right here at 0, 0. Your axis of symmetry is always going to be x equals. In this case, it'll be x equals 0. If I fold right down x equals 0 there, that is where if I fold it along this line, it would be symmetrical. It lines up. The y-intercept is at 0, 0. The x-intercepts are at 0, 0 because they all cross right here. Again, this is a pretty simple one. There's nothing too complicated on it. This one has a minimum. Now our domain is going to be all real numbers because you can plug in whatever you want for x. You'll eventually get some sort of y value. Notice it keeps going up here. Our range in this case will be y is greater than or equal to 0. Okay. Let's look at what happens if we kind of add a different number in here. So now we got like a plus 3. So I can go back to my Desmos and I can do a plus 3. Where's my Desmos at? Here we go. So I can just put like a plus 3 and notice the graph just moves up 3 units there. Okay, so again, I'm just going to pick some of these points here to plot and make it easier, and that's how I got this here. So let's look at some of the key features for this graph. Let's see what we got here. The vertex now is at 0, 3. Axis symmetry is still x equals 0. It will be other things as we look at other graphs. The y-intercept happens to be the same as the vertex 0, 3. Notice what happens here is you don't have an x-intercept. And that can happen too. We don't cross the x-axis. This one's still a minimum. Domain is always going to be all real numbers. You can pick whatever you want for the x's. Range this time is greater than or equal to 3. Because see, if I go here, I'm not using any y values until I get to 3, 4, and so on. All right. And we can look at other graphs too if you want to, but that's kind of like the basic idea. I want you guys to try out some. Use that Desmos or use your graphing calculator to graph some, get some key features. You can always come back here and check. I'll post the answer key for the other practice here, and let's see what you guys come up with.